Okay. So yesterday, what did we discuss? We just started the function, right? Okay. So today we'll try to continue that, and we'll try to get into the lambda functions, which is very, very important for the PySpark. And we are going to use it very regularly regarding the lambda functions. Okay. So before we understand the lambda function, I told you, right, the function. So the function structure I've explained yesterday. So every function starts with def. Def is a keyword, and max is a function name. Okay, and this one a comma b are the formal parameters. Okay, and colon is a, what is that colon? Indentation
Indentation.
symbol. Okay, so whatever the block you are writing inside the function, you have to write with indentation. So if a greater than b, return a, else return b. This is the function logic or body of the function. You can call it in any way. So what exactly this function is doing? So that we are indicating within triple single quotes or triple double quotes. So that we call it as a doc string. Okay. So and after that, how to call the function? So you have to take one variable here equal to the function name we have to call, and we have to pass some arguments to that one. So these are called arguments. These are called formal parameters. So arguments will be mapped to the parameters actually. Okay. So 6 and 4 are the arguments. Now we understood everything, right? So we'll try to create one function. Is even function will try to create. Okay. Whether given number is even or odd. So that is what I wanted to check actually. Now come and tell me how to open Jupyter Notebook. Can you help me? I don't know that. Can you help me that?
In Anaconda.
Okay, we have to open the Anaconda prompt. Now what
Yeah.
I need to type here?
Jupyter space
Jupyter
notebook.
Notebook. Okay,
Yeah.
just hit enter here. Then what will happen? Back and it is going to open the Jupyter Notebook. I'm just clicking on OK here. Sorry. Now yesterday I think we have created one file, right? What is that file? You can see that file here directly. I think what
Python
did I create
functions.
yesterday? Python functions, huh? I think this is the one. A day ago. See?
Yeah.
1 day ago, I've created this notebook actually. Okay, you can click on directly on that notebook. So wherever you left yesterday, right, the same thing will be opened here. Okay, now let's try to create the even function, even or odd function, and the add function also. Add function anyway yesterday I created. Without return statement, I'll create. With return statement also, I'll try to create. Okay, so first let me try to create here.
Shiva, sorry to interrupt.
Yeah.
When we click on the Jupyter, the
Uh-huh.
Anaconda prompt, I did not get the Jupyter notebook, Shiva.
Jupyter Notebook is
it?
installed. So what
No,
you
no,
can
no.
do is,
It's not installed.
then you have,
Sorry.
then it has to be
Okay.
installed actually. Along
Okay,
with
it's
the
a
Anaconda,
you
when
have
you
open
install
source
Anaconda,
or
automatically you'll get it.
Something like
Along with Anaconda, it will automatically gets installed actually. So did you install Anaconda distribution or normal
yes,
Python?
yes, Shiva. No, Anaconda distribution only. I mean Anaconda
Right?
prompt. I just I'm into Anaconda only now.
Mm-hmm.
Python I'm able to do. Python commands and everything I can execute what is
Okay.
related to the Python. But when I type, it's a JUPYTER only, right?
Jupyter,
So it is
yes.
using Jupyter-H version config dir. I think Jupyter also installed, but one of the argument version.
When you type in your search Windows search box like this, are you able to see this kind of one? This kind of one or this kind of one symbol?
Yeah, I can see Jupyter Notebook Anaconda 3 app. Yeah, now I'm able to open this Anaconda.
You can click on this one also, no problem.
Yeah, I opened that one. Yeah, thanks, Shiva. I
Yeah.
can now see.
Okay. Okay, so if at all if you want to create a new cell, right? So you have a plus symbol here. You need to click on the spread symbol and you can start writing your code here. Okay, come on, help me here. So I wanted to know actually whether it given number is even function, even number or not. So for that, I have to start with every function starts with a keyword called def. Okay, so my function name I am taking as is even, and I'm going to pass single number. We are going to pass or multiple numbers.
Single.
Pair of numbers we are going to pass single number, right?
Single.
So I can take here.
Single number.
Yeah, so I can take here a, or you can take any variable, guys, here. So there is no guarantee that every time you have to take A and B, X and Y, P and Q like that. No, anything you can take here. Okay. Or you can pass it as a number also, like this. Okay. So simply I'm taking here A. Okay. After that, function definition I've written here. I mean, function name I've written here. And formal parameters also I've defined here. After that, colon, indentation symbol also I've given. And after that, hit enter. See where it is showing here. After two spaces, it is showing the space here, cursor here. Now, you have to write your own logic here. Now, what is that I need to write here? How to know whether it is even function or not?
Divided by 2.
Divided by 2. So directly can I
Yeah.
take the logic here without assigning a variable? See guys, one thing you need to remember here, you can directly write your logic inside the after return here, or you can, yesterday we have written right here. Yesterday we have written C equal to, for adding the numbers, C equal to A plus B are written, right? So this C we call it as a local variable. This C we call it as a local variable. Here I don't need to create a local variable. Directly today what I will do is I'll simply write here return. So here if A return A percentile means what? Percentile means what will happen? What it will give?
Reminder.
Reminder or quotient? Reminder or quotient?
Reminder is
Reminder.
0. Yeah.
So if you get, let's say if I take 5 here, 5 percentile 2 means what you'll get?
1.
1 means it is it an even number or odd number?
Odd number.
Okay, so if I take a percentile equal to 1, then I can directly write here. So whatever the logic inside, okay, if at all if you want to write the print command inside that one, you can write it happily. Okay, so if you want to find out whether it is even number or not, like directly you can take here equal to 0 or equal to 1 based on your logic. You can write it here. Okay, so I'll write it here equal, not since you are comparing here, double equal to we need to take. Okay, so since you are finding out here even number, then I'm taking here, if it is odd number, you can take 1. So since it is even number, I'm taking here 0. Okay, fine. And after that, what we need to do? We need to call this particular function. Now, how to call that particular function? See, there is no guarantee that you have to write the print command inside the function. It's up to you. If you want to write it, you can write it happily, no problem. Okay. Now, even if I try to execute backend, is it going to be executed? Even if I try to execute, we can run here until you call that function. The function body will not be executed, guys. Until you call that particular function body will not be executed. Now, how to call that one? How to call? Is underscore even of some argument we need to pass right here. Let's say I am passing 5. Passing 5. Okay. So let me try to execute this one. Whether it is even or not. False. It's not a even number. It's a odd number. If I take here 4, then what will happen? I can take directly 4 here, and answer you're getting is true. Okay, you can change the logic also here. If you want to find out the odd number, is odd. Is odd you can take here. So instead of 0, you can take here 1. That is also okay. Now, is even of 5 if I take here, yes, it is equal to 1, right? True, right? Okay, I think I need to execute this. Yeah, true. Now we are getting it. True. So like that, whatever the logic you want, you can execute, guys, here. Okay. Sorry.
Why it was giving false before Shiva?
I think it was not called here. Now it is executing. Now without executing the cell also it can be executed. Because when you call the function, automatically this body will be executed. Now if I change it to 1 here, and if I try to call this one, this has to be executed, right?
Now function definition,
Can
if we
be-
change, we have to execute the function definition, right, Shiva?
Function definition we have, body will not be executed, but function will be executed right here. So it is actually taking the previous logic only, whatever we
Yeah,
have
Okay.
written.
yeah.
Okay.
Before you changing to the one,
Yes.
that is taking this only.
This one only, correct.
That is correct only.
Correct. Behavior is correct. Okay. Body will not be executed. That's it.
Yes, correct.
Okay. Now this is okay. This is okay. Fine with this. Now what I will do is, once again I wanted to repeat this add function, and I wanted to see that return is not mandatory. I wanted to prove that return is not mandatory. Okay. So what I was doing is, yesterday I was trying to assign the output to a variable. Now what I will do is, simply I'll take like this only. I'll just remove this return C. Will this get executed? Will this get executed? Yes, this got executed here. And if I try to call this particular function and print off output, what is your expectation here? Can you guys guess it? Can you guys guess it? Can you guys guess it?
Addition of the two numbers.
You're going to get the output?
3.
3 you're going to
Yeah.
get. Okay, let me execute this one.
Not sure, Shiva.
What you're getting here? None.
Yeah.
Why you're getting none here? Can you guys guess it?
Because we are doing the operation, but we are not taking the value, and we are not
you're
taking
capturing
back
that
to
output.
the function call, right?
You're not capturing that output actually. Okay, so you have to capture that output through return statement. So return is not mandatory, but it will be useful for capturing the output actually. So when you call the function, right, you have to capture that into some variable. So that variable value, if you don't define the return here, you'll get none. None is nothing but a nothing, null. Okay, so that is what I wanted to prove here. Okay, fine. And one more example I have here. This is addition example, same thing I've given. If you want to write the print statement after that, you can write it happily, no problem. So let me do Control Z here. Okay. So this is about the basic functionality of the functions. Actually, to be frank, if at all, if you want to learn about the functions, right? So many things are there. So for PySpark point of view, this is enough. This knowledge is enough. Okay. So we are going to use up to this level. This is enough. Okay. Now moving on to the next version of the functions, that is lambda functions. Okay. See, every time so far what we were doing, we were creating the functions, we were creating the function and we are calling that function. Even for the small logic, we are creating that function and we are calling that. See here, with the help of lambda functions, you can avoid that. What you can avoid? Creating the function and defining that one and calling that function. We can avoid all those things. Okay. So without the function, without a name, we call it as a lambda function. We don't need to define it actually. Instantaneously, we can define and we can use it. So such kind of functions, we call it as a lambda functions, or sometimes we call it as a anonymous functions also. Okay. So example, I'll try to give you so that I'll come back to this one again. Okay. So best example for that one is addition example here. Add is just a variable. That's it. Add equal to lambda. You are telling to Python, hey, I'm going to create a lambda function which doesn't have any name. Lambda. So to the lambda, after that lambda, you have to define the formal parameters here. That means arguments for this one. Okay. So x comma y are the parameters of the function. So and after that colon, simply you have to mention colon and you have to mention your logic here. See, anywhere am I defining any the function name here? No. I'm just assigning this logic to the variable. That's it. Now result equal to add of 5 comma 3. Directly I can call this particular variable here. And the result you can assign it to some variable. And you can print that one if you want. So does it have any name? No, it doesn't have any name. So if you have a small requirement, I mean simple logic if you have, and you don't need to create any function. If you create a function, what will happen? Backend it is going to create an object. So which this, with this kind of like lambda functions, right? You can avoid those function definitions and creating an objects and all those things. Okay, now let me come back to theory part here. Lambda functions does not contain name explicitly. Yes, of course, it doesn't have any name here. That is the first point. And next, sometimes you need a simple arithmetic function which can perform instance operations. That's what I mentioned already. Okay, it is silly to write the method for it, but redundant not to. I mean, simple function. It's a simple function, very simple function. You cannot reduce it. You cannot reduce the number of lines there. Very simple functions we can define. So with lambda, we can create a quick, simple functions. Of course, return statement is not required for the lambda functions. You don't need to write return exclusively. That is not mandatory. Okay, they're often used for the short one-time operations and are particularly useful when you need to pass a function as an argument to the higher order functions like map, filter, sorted, and all. Okay, so we are going to see these higher order functions today. I'm going to explain that one at that point of time. So facts about the lambda functions are lambda functions can only be comprised of a single expressions. You cannot write multiple lines of code. So just like see, actually in the add logic here, if you want to write multiple operations, you can write it. But in lambda function, you have to write a simple expression and single expression. Simple and single. You cannot write 10 lines of code, 20 lines of code. You cannot write like that. Simply one expression you need to write this expression. That's it. So that is about the lambda function. No loops, no calling of other methods. They don't allow any loops here. For loop they don't allow, while loop they don't allow. Inside the function definition. Inside the function logic I can say. And the last one, lambda functions can take any number of variables. So here it can take any number of variables here. Okay, so this is about that one. So we'll try to create a simple lambda function, guys, and after that we'll get into slowly the higher order functions, which are very important for the PySpark. And do remember here, whatever we are going to do today, the same thing we are going to do from Monday onwards. Everywhere we are going to create a lambda function. Everywhere. Okay. Even in the interview point of view also, these lambda functions are very important. Okay. So let me get into that one. How to create that. So I'm just copying this one. I don't want to type it actually here. So let me create new cell here. Yes, this is the one. So add is just a variable equal to lambda. Lambda is nothing but if you give this particular keyword here, then it will understand, okay, so this doesn't have any name. So I have to take the expression here and I have to evaluate it. That is what it understands. Okay. Result equal to add of 5 comma 3, two arguments I'm passing here, and I'm trying to print the result here. So let me execute that. See, output you're getting directly 8. 8. Okay. So if you want, you can create one more function here, average function. So simply you can take like this. Simply you can take like this. So average equal to lambda of x comma y colon x plus y divided by 2. So let me take here average of 2 comma 7. That's it. Okay. So let me execute this. See, output you're getting 4.5. The output of the average function is 4.5. So 2 plus 7, 9, right? 9 divided by 2, 4.5. You can take like this. Okay. Now I'm getting into the actual topic of this one. That is higher order functions. So here also I mentioned the some examples here. Um, get first letter of the lambda I've created the function to find out the first letter in a given string. Okay, lambda s colon s of 0. S of 0 means, so string also will be stored like a list, right, in indirectly in the backend. So s of 0 is nothing but first character you'll get. So output you can get like this simply. Okay, now so generally we'll try to do this kind of requirement, guys. Generally we'll try to do this kind of things actually. Okay, so length of x. Let's say I've given a string actually. I wanted to find the length of all the elements. Length of all the elements. Then how do you do that one? That is what we are going to discuss in the higher order functions. Okay. Now, what is higher order function? What is the definition of that? So just give this answer straight away if anybody asks this question. If we use function inside the function, or if any function is accepting other function as an argument, such kind of functions we call it as a higher order functions. So any function is accepting as another function as an argument, then we call it as a higher order function. In Python, we have many higher order functions. So among those things, important ones are map, reduce, filter, chip, which we are going to use frequently. Okay, many other things are there, but only important things I have taken here. Okay, now first we'll go one by one. What is map higher order function? See the definition I've given here. Higher order function is a function. It is also a function. Map is a function. It accepts other function as a argument. See, so far for the functions, we have given arguments 2, 3, 1, 5, 4, 5, like that I've given, right? Now I'll pass a function as an argument to this function. Then how do you do that one? Okay. Now first I'll try to understand here map. The syntax of map function is map of function whatever you wanted to pass an argument that you have to give here. And after that, iterable 1, iterable 2, and so on, any number of iterables you can give. Now, what is this iterable actually? What is this iterable? Iterable is nothing but like a list, tuple, set, and so on. What are all the collections we have understood, right? So all those collections, any of the collection we can mention here. We can mention here. Okay. Now, what does it do, Siva? Let's say I'll try to take one list here. What does it do? This function, whatever you're defining here, this function, the logic will be applied on every element of this particular iterable one. This function logic will be applied on every element of the iterable. That is the use of map. So let me try to take one example here so that you will understand. So here, let's say I'm trying to define a lambda function like this, guys. Lambda function, I have to create a lambda function, or you can use the existing function also here. No problem. That is also okay. Okay. So what I will do is I'll try to take list first like this. List equal to 2, 3, 4, 5. Now, so roots is nothing but a variable here. So map function, what it does is it will take one more function as an argument. So math is in a math module, square root is a function. Square root is a function. Math dot square root I'm taking here. Math dot square root, comma, list I'm passing. So if I say list is nothing but what? 2, 3, 4, 5. This function will be applied on 2. This function will be applied on 3. Similarly on 4. Similarly on 5. Every element, this function will be applied on every element of the iterable object. Iterable object is nothing but a list here. Okay. And after that, you have to print it. So for printing that list, you know how to print that list. So let me try to do this one with the lambda function. Guys, remember one thing here. So map will take either lambda function or predefined functions. Anything it will accept. Anything it will accept. Let's say I wanted to add 1 to each and every element of the list. 1 to each and every element of the list. Now, how to create that function, how to create that lambda function, and how to use that one here. Let's try to do that one here. So my requirement is I wanted to add 1 to each and every number in a given list. So for that, I am just opening a new cell here. For that, we need to create a lambda function. How to create a lambda function? Add underscore 1. This is my variable name, equal to lambda we are defining here. Okay, so if at all if you want to add here 1, so I can take only one variable here. That is enough. The number I'm going to pass here. So to that, actually I'm going to add a plus 1.
1.
That's it. That is the logic. Give some space here. This is the lambda function definition. Now I can use here this lambda function in any operation. Okay, for that, what I will do is add one function I've created right now. So result equal to okay, map of within map, what we need to take is this function we need to call. Okay, so directly take that one here, map add one comma list we need to mention. So did I define the list here? No, I did not define that one. So before this one, before I define the lambda function, I'll try to define the list also. So list equal to let's say L1 equal to within square brackets, I'll try to take here 1 comma 2 comma, let's say 100 200 I'll take here. So 100 comma 200 comma 400 comma 500, like this I'll try to take. Okay, so if I try to call this particular L1 here and check what is going to happen. So what I will do is I'll simply print here the list result like this. Okay, and what is that output you're getting? Check it. See here, backend it is actually created object. When you try to print it here, the print result is this one. Backend it has just created an object. That's it. That's it. So, but I want the elements from that object. So for that, what you need to do is you need to print the elements. For printing the elements from the object, what we need to do is for loop we need to use. For I in what is that we need to take here?
Result.
L1 we need to take or result we need to take? A result we need to take here. So I in result colon indentation symbol. So hit enter here. See
Print of
where it is showing the cursor here. After some indentation, it is showing here. And now what I need to take here? Print of I. That's it. I. That's it over. Let me execute this one. See, 101, 201, 401, 501. Now try to tell me here what is happening when I try to use map. The map will try to pass this particular function, apply this particular function on every element of the iterable object. You can take tuple also here. You can take set also here. Whatever you want, you can take it here. Are you guys getting?
Yes.
Okay. Guys, if you don't understand, please ask me. We are going to use this lambda functions regularly in the real time as well. Now, tomorrow onwards, we are going to create this one only. We have to create a lambda function and we have to use that one on the RDDs. So on Monday, we are going to start the RDD. So on that RDD, what function we are applying? That is what we need to understand. So map is there in the PySpark as well. Map function is there in the Python as well. Now people will ask you in the interview, what is the difference between Python map and the PySpark map? You can expect such kind of questions. The syntactical differences are there and the functional differences are also there. We'll see that one on Monday. Okay. So this is lambda function definition and applying a map on top of that. Okay, let me try to take one more example here. When you do map, what will happen? So map will try to do function, apply function on first element of the list. So next second element of the list, and it is going to produce the result here. Function applied and result here. And next on third element, on fourth element, and so on like that till last element it is going to apply that function. Now tell me here one thing. How many elements are there in the list here? How many elements are there in the list here? How
Four.
many elements
Four.
are there? Four elements. How many elements are there in the output?
4.
Four.
Four. Remember here, the most important property of the map is whatever the number of elements are there in the input iterable object, the same number of elements you are going to get in the output, because map will be
Applying the
applied on every element of the iterable object. In the output also you're going to get the same number of elements. That is the important behavior of the map. So that is what I mentioned here. So whatever the number of elements you have, the same number of elements you're getting as output. Okay. Okay. Now what I will do is here, I'll try to take multiple lists here. What will happen? We'll try to understand here. Okay. So first list I am defining here. I told you right in the syntax here, we can take multiple list iterables right here. Iterable 1, iterable 2, and so on. Any number of iterables you can take it. See, so far I've taken only one iterable here. Iterable is nothing but iteratable object. List can be we can iterate or not? Yes.
yes.
Yes, we can
Yeah.
iterate. We can iterate on top of list. Tuple also we can iterate. Set also we can iterate. Dictionary also we can iterate. All those things we call it as the iterable objects. Okay, so don't think that okay, iterable is a separate concept. No, list, set, tuple, and dictionary we call it as iterable objects. Okay, now what will happen if I try to take multiple lists here? Okay, L1 equal to, within square brackets, I'll try to mention 1, 2, 3, 4. 1, 2, 3, 4. Okay, and
Okay.
L2 also I'll try to take guys here. L2 equal to, within square brackets, I'll take here 5, 6, 7, 8. Okay, so 2 I've taken here, and after that I'll try to take here, and I'll try to take here one lambda function, that is add function. I'll try to take. I'll try to create a add function. Okay, what will happen here? How to define the add function here? Okay, add underscore fun, add function equal to, add function is a variable, that's it. Now we need to tell to the Python lambda, hey, I'm going to create a lambda function. Okay, so this one is going to take, add function generally take how many arguments? 2, right?
2.
2, right? A comma B. There is no guarantee that rule that every time you have to take A and B here. Guys, remember that. You can take any variable name, any parameter name here. X and Y also you can take, P and Q also you can take, your name, my name also you can take here. Anything is okay. Okay, colon space
A plus B.
A
A
plus B.
plus B. That's it.
B.
B. What will happen here? Okay, now I'll try to use here a result equal to map of now
Add
this
function.
add function we need. See, this map is a function. This function is accepting another function as an argument or not. So this
Yeah.
is higher order function.
Yeah.
Okay, so add underscore function comma L1 comma L2. As per the syntax I've taken. Now what is going to happen here? Come on, tell me.
It will pass to all the elements which are there in L1 and L2.
L1 and
Number
2.
of number of
Okay.
iterables.
Number of iterables. Okay, let me try to print this one. Now how to print this one? How to print it? For
Print result.
for I
I
in
in result.
result. For I in result, colon print
And
of
I.
I. That's it. That's it. Now what you're going to, what is your expectation in the output, guys? What is the expectation of the output? What is your expectation in the output here? Is it going to create is it pass L1, L2, L2? That means 1 plus 2 plus 3 plus 4, it is going to pass. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Okay, and 5 plus 6 is 11, 11 plus 7 is 18, 18 plus 8 is 26. So here
6,
you will
8,
get
10,
26,
12.
here you will get 10. 10 comma 26
6,
you will get
6, 8, 10, 12.
6,
Uh,
No.
6, 8,
I
10,
First.
12.
12, yeah.
So is
I
it going
think
to add the elements in the list, both the list?
I'll get we'll get 1, 2, 3, 4, 5, 6, 7, 8.
1, 2, 3, 4, 5, 6, 7, 8. Okay, let me print it. My answer is 1 plus 5, 6, 2 plus 6 is
Yeah,
8, 3
yeah.
plus 7 is 10,
10,
and 4 plus 8 is 12.
12.
That is what my expectation. Okay, let me print it here. See, 6, 8, 10, 12. What is happening here? What is happening here? First element in the first list is passed to the add function. I told you already, the fundamental rule of the map is how many elements you are taking here, the same number of elements you're going to get in the output.
Yeah.
That is the fundamental rule. Okay, so first element in the first list is taken and is passed to the lambda function. And second element from the second list, first element is taken and it is passed to the function. Now a plus b. So first element in the first list, first element in the second list is getting added here. That is what we are going to get here.
So Shiva, here how many are the iterable elements we have? For each and every element, it's a one-to-one mapping, right?
One-to-one mapping, correct.
Okay, understand. So if we can you put that 9 after 8 in L2
Okay.
list?
Okay. You
Can
want
you
me to
execute the
take
same?
like
One
in
extreme.
okay. So length you are trying to vary it. Correct?
Yes,
Yeah.
yes,
Okay,
yes,
let me
yes,
try to
yes.
execute. Anyway, I'm going to discuss that one, so it is not going to take that.
Oh, sorry. Yeah, sorry. So actually,
Okay.
it should
Ah,
not add and it should ignore.
yes, it has ignored right now. I executed
Oh,
already
it's
this one.
executed. Okay,
Yeah,
okay,
I
sorry.
executed already. The
Have
output
we
is
ever
6, 8, 10, 12 only again.
Okay.
Okay.
So it's
So I think
always
that is what
one-to-one
I mentioned.
mapping, and if it does not match, it's one-to-one mapping. It will ignore.
Mm,
Okay.
yes. See, the map function applies given function to each item in the iterable and returns an iterator as an object. That iterator, are we getting the iterator or not here? Result is what? Iterator or not? Result is a iterator. On top of that one only, we are trying to use for loop, right? So that is an iterator. So it's a convenient way to apply the same operation to multiple elements in a collection. Okay, you can optionally provide more iterables as a parameters to map, and it will place tuples in the result list. You can provide more iterables also here. More iterables which list 1, list 2, list 3, and so on. Any number of lists you can mention here. But as for that, you have to define the function. Map returns an iterator which can be cast to a list. This is very important one. Okay, now I don't want to create here an iterable object. I wanted to create a list on top of that directly. So for that, what you have to do is I can take here a list of directly here. Whether it is going to create a list object or not, how do we identify that? Print of come on, print of
Type.
result, comma type of
result?
result. That's it. That's it. Okay,
Spelling mistake.
let me spell mistake. Where? Oh, sorry.
Simple.
Yeah, let me execute that. See, so it is creating actually list. If I don't mention this particular list, right, what is going on here? Can you tell me? It is an iterable object. That's it. Map is producing iterable object as a result. So that iterable object I am trying to convert into either list or tuple. That is what I am trying to mention here. Shiva, why do we need to convert all these things? That is, yes, it is required, boss. It is required in the PySpark. because all PySpark APIs are going to generate output like this only, like objects only. Okay. Next, moving on. You can take like this also. Lambda x comma y x plus y. Directly you can take range of 1 comma 4. What it is going to generate here? What it is going to generate here? 1 to 4 means range of 1 to 4 means what it is going to generate?
1, 2, 3.
1, 2, 3 list, right? Correct or not?
Yeah.
1, 2, 3.
Okay.
Yeah.
See, some iterable object we need to take. It may be a list, it may be a range, it may be tuple, anything it is okay. And 7 comma 10 means
7, 8, 9.
7, 8, 9
7.
it is going to. -1 always you need to take to the end element. See, I mentioned already, all list must be of same length, but not really. But not really. It's not mandatory to maintain the length of list same here. Okay, that's what I proved now, right here, right? Even if I take 9 here, it is not considering that 9 here. Only whatever the elements are matching here, only that one it is considered. If I take here 10, then it is going to give again 19 in the result. See, if I take 20 here, let's say, and it is not going to be considered here 20 because the length is not same. Last element will be ignored here. Okay, so that is what I was trying to mention here. So the list must be of same length, but not really. It's good to have the same length, but it's not mandatory. Okay, number of list must match the arguments needed by function, of course. Since I have taken here two lists here, I need to take two variables only. If I define list 3 also here, and if I try to give here only A and B, what is going to happen? It is going to throw error. Let me try to show you that one. L3 equal to, within list, I'll try to take here 10 comma 20 comma 30 comma 40. Okay, 4 elements are 1 2 3 4 5 elements are there. Okay, comma 50 I'm taking here. Okay, if I try to execute here comma L3, it is going to give an error. Why it is giving error? Positional arguments, 2 positional arguments are there, but you have given 3. That means, boss, you are mentioning 3 list here, but you have taken only 2 list here. How do you want me to proceed? I cannot able to proceed. Guys, errors are also very important in Python and PySpark. Errors are also important. Okay, so lambda function can take only 2 positional arguments. What you are trying to give here? 3. Okay.
If I give 4, Shiva?
Where do you
Okay,
want me to do that?
limit is only 2, you mean to say?
No, it's not like that. Since you have taken L3 here, one more argument you have to take here. C
We
we
have to
need to
define
take.
that.
A
Yeah,
plus
got it.
B plus C.
See,
The
yeah,
number of
sorry.
iterable objects you're taking must be equivalent to the number of variables that you're taking in the
We're passing.
lambda function definition.
Got it.
There we need not to put the plus C, right, Shiva?
We have to put right. Otherwise, how does it take?
How it would.
No,
mm.
no.
Logic you can
I'll
take anything. Yeah.
I'll sum only A plus B.
Yeah. You can happily do that. You can happily do that. Do
Because
that.
I'm focusing on 1-to-1 relationship.
Yes.
Keep on checking.
Yes.
Okay. And
Okay.
Shiva, I have a doubt.
Mhm.
Say
Mhm.
we have here we have 3 parameters. Okay.
Mhm.
But in add function, if I pass two, then also we'll get error. Huh? So remove the L3.
Okay, I am trying to remove
No,
L3,
remove
but I'm
L3.
trying to take here A comma B comma C. Okay,
Yeah.
let me
Yes.
insufficient arguments right here. See,
Okay.
missing one required positional argument, that is C.
Okay.
It is saying that lambda is actually like lambda C is there, but where is that C related list?
Yes, that's okay.
So that is the issue.
L3.
Okay, give L3 here. and I can miss the this one also. See, I can miss the C here. I can add only A plus B. No problem. You can multiply also here. You can multiply here. Yes, you can do that. Do whatever you want, whatever the logic you want, you can do that. Minus also you can do that happily, no problem.
We can do just B and C also, right?
B and C combination also okay.
Okay.
Okay, so let me try to take here. Okay, 1 second. B plus C. See what is happening? You're getting or not? B and C means list 2, list 3 elements will be considered here. Okay, so this is about the map. Remember guys, I'm not going to spend much time in PySpark for explaining the map function. The same functions you can see in the PySpark as well, but the only syntax will change there. That's it. In place of iterable object, there it is going to take RDD as an object. RDD dot add I'm going to use there. Sorry, RDD dot map. So the notation will change there, but the functionality remains same here and there. So map is just a iterable map is just going to iterate on all the objects. Sorry, on all the elements of the object. That's it. One-to-one mapping here. Map is nothing but one-to-one. Okay, now moving on to the next one. Filter function. Next one is filter. Let's say from the list actually I wanted to filter some elements from the iterable object. Actually, if you want to filter some elements, right, then we are going to use this filter function. Filter is nothing but it is as simple as your where condition in the SQL. Okay, select star from employee table where department number equal to 10. It is as simple as that. Okay, so in place of records here, what we are taking? Iterable object. Iterable object. Okay, let me try to give you some example here so that you will understand. Let me create a new cell here. Okay. Okay. First syntax I'll try to show you here, and after that I'll move on to the other one. Okay. So filter off. Filter off. Again, we need to define here the function. Function you can define outside. Sorry. Function you can define outside. That function variable name you can take directly here. You can take directly here. And after that, you have to pass again here the iterable object. This is the syntax of that. Okay. Let me try to take that one here. Same example, I can take it here. Let me explain that. Now, so numbers equal to, I've defined some numbers here. So non-zero numbers, I wanted to filter out actually. Non-zero numbers. Okay, for that, so numbers equal to same object name I've taken, whatever the list name I've taken, same object name I've taken here. List of, I'm converting ultimately into list. Filter of. Filter function will take only, function as an argument. Okay, comma, on top of what you wanted to apply, on top of numbers I wanted to apply. Non-zero values, the function will be applied on every element of the list here. And it is going to try to print it. Okay, let me execute this one. See what is happening. See non-zero values, it is displaying. In the filter, any guarantee that you're going to get the same length, iterable length here in the result?
No.
No guarantee here. Only in the map that is applicable. Can I do this now? Okay, so let me check here. Any other example I've given here? Let's say from the given list, I wanted to find out actually even and odd numbers. Even and odd numbers. See, this kind of questions you can expect in the interview case. See, for generally, if I give you a list here, if I ask you to filter out the even numbers and odd numbers, generally what people do, the core programmers, they'll try to create a function separately, is even function. Okay, or odd function they'll try to, or even odd function they'll try to create, and they will apply these things again on the function. they're going to pass these elements an argument to the function. You see, you don't need to do all those things here. You can directly define the you can directly define the you can do like this also, but you don't need to do that one. You can directly define the lambda function inside this one, and you can filter it out easily. I told you already, this filter function or map function, not only lambda function it is taking as an input, normal function also it can take as an input. Normal function. Normal function. This is normal function, right? Define is even is a normal function. Okay, and one more thing, guys. Filter will keep, filter will hold values only whenever the function is returned true. Whenever the function return true, it will hold only those values. You know what will happen here? So 2 will be passed to the easy one. X percentile 2, x is nothing but 2. 2 percentile 2 equal to 0 or not? Yes, true.
Yeah.
So since it is true here, it is holding that value. And second one will be passed here. 7 percentile 2 equal to 0. True or false?
1.
False. False means it will not hold that. Even in SQL also it does. It works in the same way. Even in Python also it works in the same way. Filter concept is straightforward, guys. For whatever the records it is returning true, only it those values it will hold. That's it. Okay, that is about the filter. Next, last but one is reduce function. Reduce function. So for if at all if you want to use reduce function, right? So you have to use its module name as well. Function calls is a module name. Inside this module name, actually, we have a function called reduce. Okay, so syntax is similar to your other functions only. This is also a like a higher order function because it is taking function as an argument here. So reduce of function iterable objects you can mention, and initializer also you can mention. This is very important option here because we have multiple combinations are there in the PySpark here with this initializer. Okay, we'll see one by one here. We'll try to understand one example here. So let's say if I try to take here this particular list, okay, I'm copying the same thing here and I'm trying to paste it here. So numbers equal to 1 2 3 4 5 6 7 8 I've taken. Or range of thing also you can take here. Range of 1 to 9 also you can take it. So in place of this one, how to take this one range? How do I use range? List of come on. How do I take
Range
range
of
of
7 comma like
uh,
that.
one is required. Can I take one here?
No need, no need. Just
Okay.
you can
If you
give the
want
10,
starting
so it will
number,
take 10.
only in the case of starting number, you have to give the number. Directly, I can give the 8 right here. Happily, you can take it.
Yes.
What happened? Reduce is not okay. So you need to import that one actually here. Okay. So import function calls. Function. So what is that method name here? Function calls, right? I'll try to call this one. Okay, let me execute this one. No module name function calls dot reduce. Okay, one second. From function calls, we need to take one second, just a second, guys.
Put
From here and import reduce. This is the correct one. See, print is not defined here. Where is the print here? Where is the print? Oh, this one. Okay, small letter we need to take here. Capital letter we take. See, output we got like this. But this is not the output actually. This is not the output. This is not the output. Okay, now what will happen, the function I'll try to take here x plus y. Let's say if I take x plus y here, what is happening here? X comma y, x plus y. One second, let me remove this one and numbers. What will happen here? Int object is not iterable. Where is that? Okay, list is not required here. List is not required. Directly I can take here this one. See, output you are getting 36. Now what is going on? Can you tell me? What is going on here? Can you tell me? I'll try to print the numbers here. Okay, print of numbers.
1 to 8.
NUMS. Now what is going on here? Can you guys guess it? Based on the output or
1
the
plus
input,
2
you try
plus
to tell.
3 plus 4 plus.
So reduce is actually
Just added all the numbers.
is actually adding to the next number. Now how is it happening? That you try to do bit research and get back to me on this one on Monday. Okay, and one more function is left over, guys. That is the last one. That is zip one, which is this one also very important one actually. And reduce also we need to see more examples, because the same function we are going to use in PySpark as well as it is. So instead of spending time there, I'll try to spend here only more time. Okay, and last function is zip. This is also very easy one. So already we have seen this zip. Where did we see that? Where did we see that? Where?
While creating a dictionary.
Dictionary, exactly. Okay, so but we'll try to understand more depth about this one. Okay, yeah, that's all for today. Now lambda functions are damn important, guys. Damn important. So in the next class, we'll try to continue the zip and the reduce, and I'll try to discuss about the packages and the modules as well, which is very easy one. Okay, and after that, I'll start the PySpark introduction. Yeah, guys, I'm stopping.